Hey guys, and welcome to my channel. In this video, I will be talking about Azure Eventing and Messaging Services, which are Azure Event Hub, Azure Event Grid, and Azure Service Bus. This is a topic that really confused me when I first started my Azure journey, so I hope to make this as simple as possible. With that being said, let's just get into it. There is massive confusion around Azure Eventing and Messaging Services. We have Azure Event Hub, Azure Event Grid, Service Bus, and all of those services, which makes it very confusing to know when to use what. When I first started my Azure journey, I never found a good explanation of the difference between all of those services, and my goal in this video is to explain all of those services by example. Before starting, the big question that led to creating those services is, how are my applications talking to each other? Okay, and you might say, well, Abdullah, we can just make a direct network call between the applications, and you would be right. The traditional method, which is the request response, is what runs most of the internet actually. And this is a very simple example. So you would have application 1 making an HTTP request to application 2, expecting a response from application 2, where application 2 sends back a response to application 1. And in this case, this is what we call asynchronous communication. Synchronous communication means that application 1 is expecting a response from application 2. And again, this is essentially what built and what powers most of the internet. However, the question is, when does this fail? And the answer to that is microservices. So let's say we have a microservices architecture that is using synchronous communication, which is the classic HTTP request response. In this case, I just have a web server which serves content. I have the payment processor service, and I have the order processor service, again, in a microservices application. Let's say a user submits an order, in this case, to our e-commerce website. What happens here is that our web server will make a direct HTTP call to the order processor service to process the order, and the order processor in turn makes an HTTP request to the payment processor. Okay. Now, after the payment processor is done, it sends back a response to the order processor, and then when the order processor is done, it sends back the confirmation that the order is completed to the web server. Now, you might ask, okay, so what is the problem with this architecture using synchronous communication? The first problem is that the request is as fast as the slowest request. So let's say the user just wants to simply retrieve the list of his orders, okay, so the historical orders. What would happen here is that he would make an HTTP request to the web server, okay, and the web server would then make a request to the order processor in order to get the list of orders, okay. That web server can be the fastest web server in the whole universe, okay, but if the order processor is slow, okay, that web server is actually slow as well, okay. So the point from all of that is the request is as fast as the slowest request, okay. Now, the second and probably the most important drawback in this case is the fact that there's a huge dependency between all of those services, okay. So in this case, if the user wants to retrieve a list of orders, if the order processor is down, then the user won't be able to get the list of orders. Okay, so there's a huge dependencies between the web server and the order processor in this case. And the same is true with the order processor and the payment processor. Okay, there's just huge dependencies between all of them. So if you make a change to the payment processor, you're probably going to also make a change to the order processor as well. Okay, so with software engineering, we want to typically have these services with social anxiety. So we don't want those services to be able to directly talk to each other. And again, this request response, it is what powers most of the internet, but when we start talking about microservices and distributed systems, we have to think much further than that. This brings us to the pub sub system, which is another way for applications to talk to each other. So with a pub sub system, you have what we call a message broker or an event bus. And we will get into the difference between a message and an event later on. So in that bus or broker, you would have a series of topics, okay? Applications or services would publish events to those topics, and we will have subscribers subscribing to specific topics to get notified whenever anything is published to those topics, okay? So, for example, in our e-commerce application, the client would submit his order, the web server will publish a message, maybe in JSON, to the order topic with the contents of the order, which is what the user ordered basically. And because the order processor is subscribed to the order topic, he will receive that message from the order topic, does the processing, and then publishes another message to the payment topic, okay? And because the payment topic, the payment processor is subscribed to the payment topic, the payment processor will get that message and then does the payment processing and then publishes another message back to the payment topic, and maybe you'd have the web server subscribing also to the payment topic, looking for messages that indicates that the payment is completed. And after that, the web server would notify the client that the order completed. Now, you might ask, like, why do we need such a huge complex system? Well, there's a lot of advantages to using this architecture, which is the pub/sub model. For example, you can do any changes you want to the order processor, whatever you want. After you make those changes, you don't have to worry about making changes in the payment processor, for example. And the same is true with the web server service. Okay, so there's just complete decoupling between all of those services. And again, we're back to the original problem or original question. How are my applications talking to each other? In this case, we have decoupled these applications from each other and they are not talking directly to each other, which means that you can make any changes you want to one of those services and it won't affect any other service, okay? That means that you can introduce changes to specific services much faster. Now, this is great for microservices architecture where there are several components and it makes communication much easier and more efficient. Now, obviously, there are some drawbacks to this architecture, and the main drawback is the huge network saturation and the fact that the message broker or event bus must be extremely resilient because there are a lot of dependencies on this system right here. And that is the pub/sub model. So we spoke about request response and pub/sub system, which really again answers the question of how are my applications talking to each other? And the final method is what is known as queuing. Let's revisit the pub/sub system, and within this pub/sub system, you will typically have an application publishing a message or an event, and you will have multiple consumers consuming that same message or event. So this is known as a one-to-many relationship. However, in a queue, you will have an application publishing a message or an event to a queue, and that is then consumed by only one consumer, and that's it. So it's a one-to-one relationship. So if you know that a message is only consumed by a single application and you want that to be consumed by a single application or by a single worker, then you would use a queue. So there are a lot of applications to queuing, and it is present all around the internet. It is commonly used in what is known as the web queue worker architecture, which is what you see in this diagram here. So I'm going to keep it very simple, guys. If you know that a request will take a long time or unpredictable time to process, you can write it to a queue instead of waiting for the full response of it to notify the client that the request is acknowledged. So in this case, we assume that the worker service is executing a complex process that might take a long time. So because we use queuing, we let the user know that, hey, we placed your request in the queue, okay? It is being processed and we will notify you when this ends. And one of the products I support, Azure Automation, is a perfect example of that. You have worker services executing complex PowerShell scripts, and you only want the script to be executed by only one worker rather than duplicating the work across multiple workers. So that is a perfect example of when you would use this architecture, or when you would use a queue. Another common application of queues is load leveling. So if you have flood of requests on that web server, so let's say that there's suddenly a very high traffic going to that web server, this queue actually can act like a buffer, essentially slowing things down. So in this case, the worker service can grab those messages at a steady pace because, again, they are placed in a queue, okay? And the web server in this case is the only service that's getting the huge number of traffic, okay? That's not the case with the worker service because, again, we are relying on the queue to act as a buffer. So load leveling is another very common application of using queuing. And that brings us to the end of those of the different ways that your applications can talk to each other. So the first one is the traditional request response. The second is the pub/sub system, where you have a series of topics and you have multiple consumers consuming those events or messages. And the final method is queuing, where it's a one-to-one relationship, where you push something to a queue and you'd have only one consumer consuming that thing from the queue. So we spoke about request response, pub/sub system, and queuing. Now let's talk about the difference between an event and a message. Those terms are scattered all around the internet and it makes it very confusing. If you work in tech, you have to know something. We like to confuse you guys with terms because that's what we do. It won't be fun if we didn't. I'm going to keep it really simple. An event is a piece of information that you publish or emit and you don't care about who receives it or consumes it. Your goal is just to emit that event and that's it. Typically, events are like state changes. For example, something that got uploaded to Azure Blob Storage is a state change. You emit an event that something got uploaded to Blob, but you don't care if anyone acted on that event. There's no expectation of delivery or consumption is what you have to remember with an event. A message, on the other hand, has expectation of delivery, and typically you want the processor of the message to confirm that the message has been processed. You don't just publish a message and not care. You as a publisher is expecting that message to be processed and if not, to act on it. So with events, you publish something and not care about delivery or consumption. With the message, you publish something and you expect it to be processed. The difference is super important to understand because it will allow us to understand why we have all those different messaging and eventing services on Azure, which are Azure Event Hub, Azure Event Grid, and Azure Service Bus. Let's talk about Azure Event Hub. Azure Event Hub is a data streaming service, and a data streaming service is a service that you continuously send data to it, and it streams that data to multiple consumers. Just like you have Twitch streaming gaming sessions to consumers, you have Event Hub streaming data to multiple consumers. So Event Hub is actually like a Kafka broker, if you are familiar with Apache Kafka. But in Event Hub, the broker is called a namespace, and the topics are called Event Hub instances. So in Event Hub, you have the Event Hub resources on Azure, and in that resource, you can have a bunch of Event Hub instances. So you can think of an Event Hub instance as a topic inside that Event Hub resource. And the advantages of using an Event Hub is that it is designed to handle millions of events. And secondly, but most importantly, it's designed to not lose data at all. And now let's move to some of the terms that you will see scattered around Event Hub. The first is the partition. So each Event Hub instance is partitioned, where the minimum number of partition is 1 and the maximum is 32 partitions. So the huge pile of messages sent to an Event Hub instance will be load balanced through the partitions. So if you literally zoom into that Event Hub instance, you will have a series of partitions there, and you have the messages being load balanced between those partitions. So the partition itself is actually ordered by time, so from oldest to newest, but not across the partitions. So if you want to ensure that you have ordered data, you need a partition key to publish to the same exact partition. We also have what we call event producers, and those are services that produces events. So examples are like Azure services, where you would configure diagnostic logs, but you could also send events from your custom applications, which you can use Azure SDKs for that. And then you have what we call event consumers, and those consumers can be your applications, which do some data processing or event processing on the events that gets published to those Event Hub instances. We also have what we call checkpoints and offsets. So an offset is the event or data position within a particular partition, okay? And this is there so that each consumer will know which position it reached. And checkpointing is a way to save that offset. Actually, that offset is saved in a storage account. And the reason why we have checkpoints is because if the consumer application that's processing that data restarts, it will have a place to continue, and it will not start from the beginning. Because again, guys, we're dealing with millions of events in this case, typically with Azure Event Hub. Saving the checkpoint actually in Azure SDK is done out of the box, so you don't have to worry about that. That's the nice thing of using those Azure SDKs. Lastly, we have what we call consumer groups. And a consumer group is a unique view on each Event Hub instance data, okay? So each one of those consumer groups will have a separate view. Each consumer group, in other words, has its own offset and checkpoints. So In simple terms, let's just say that a consumer group is an application that will do the event hub processing. All right, let's go through a quick demonstration of how you would produce events to event hubs and consume those events. So again, in an Azure Event Hub resource, you can create several Event Hub instances. And if I want to demo that real quick, you have what we call entities, which are Event Hub instances. And in this case, as you can see, guys, I have a lot of different Event Hub entities. I will start by demonstrating the Abdullah instance. Okay, in this case, it has only one partition, but again, you can create up to 32 partitions. The most important thing you have to create when you are dealing with Event Hub is what we call shared access policies. And this is a connection string that you use to either produce events to that instance or consume events from that instance. So in this case, we can have a shared access policy on the whole Event Hub or on a specific Event Hub instance, and it is recommended to create that shared access policy on a specific Event Hub instance. In this case, I already created a shared access policy, but if I want to demonstrate that real quick, you would define the permissions here. So in this case, I only want to send messages or events to that Event Hub and listen to events on that Event Hub instance. And I already did create that. What it will do is just create a connection string that you will use in your application. Now let's move to Visual Studio Code to quickly demonstrate how you would produce or send events to Event Hub and consume those events. So in this case, I'm using the Azure Event Hub SDK, and all you have to do is, this is a very simple code. You just have to define your connection string, which again you create, or you will get after you create your shared access policy, and you would have to define your Event Hub instance name. In this case, it's called Abdullah. In this case, I'm just demonstrating sending those 3 events. And then on the consumer application side, we define again the connection string, which is already created from the shared access policy, the Event Hub instance name, and we define the consumer group, which again is the unique view of each Event Hub instance. In this case, I'm going with the default consumer group that is again created by default. So if you go to consumer groups under that Event Hub instance, you will by default have this default consumer groups. Obviously, if you have multiple applications, you can create different consumer groups for each application. And the reason why you define storage account URLs in this case is in order, again, to save those checkpoints. Just in case our application restarted, it will have a place to continue from. In this case, all I'm doing is just console logging the events I am consuming from Event Hub. So if I want to demonstrate sending those events, so let's go back to the first piece of code. I'm just going to run this application. So node app.js. And then I would run actually that one while this one is receive.js. So if I want to go back to, as you can see here, we have a batch of 3 events being sent to that Event Hub. Okay, so I'm logging that after sending those messages. And now my consumer application, as you can see, guys, I have read those messages that I have sent. So first message I have read is first event test, second event test, and third event test. So again, all I'm doing here in this receiver application is just console logging, but typically if you have an application, you would actually process those events and then you would maybe send it to an analytics service for data analytics. Now let's talk about Azure Event Grid. Azure Event Grid is an event routing service, meaning it is a service where you publish events to topics and it routes those events to subscribers, which then can trigger certain outputs like Azure Function or Webhook, for example. Now, Azure Event Grid is different than Azure Event Hub because in Azure Event Hub, you have consumers pulling events from Azure Event Hub instances. So it is a pull model. In the case of Azure Event Grid, it is actually a push model where when you publish events to topics, you will push those events from topics to subscribers. So it actually is a push model rather than a pull model. So it doesn't depend on the subscribers pulling the events from the topics. It just pushes those events to subscribers, and then the subscribers are responsible for triggering outputs like Webhook, Azure Function, or even sending messages to a service bus queue. Now, in Event Grid, we have 3 main things. The first is the events, and the events can be custom events that you emit from your applications, or you can leverage what we call Azure built-in events. So many services in Azure actually emit built-in events that you can leverage in Azure Event Grid. So example of built-in event is like uploading to storage account. That's an example of a built-in event that you can then push to subscribers to then trigger certain things like Azure Function, for example. Next, you have an event grid, and Event Grid actually contains two resources. The first is the Event Grid topic, and the second is the Event Grid subscriber. So the Event Grid topic is where you publish events to, and the Event Grid subscriber is where you subscribe to the topics, and then you would trigger certain outputs. Lastly, you have, again, the outputs where we can configure subscribers to trigger something when something is posted in the topic they are subscribed to. In this case, we have Azure Functions, Webhook, and Service Bus Queue. Now let's do a quick demonstration. So in this case, I created an Event Grid topic resource on Azure called Demo Topic. And actually in an Event Grid topic resource, you can add event subscriptions. So whenever you post to those topics, the Azure Event Grid topic will push those events to the subscribers, and then the subscribers would then trigger certain outputs. So in this case, if you want to create an event subscription, you would give it a name, and then the topic type in this case is an Event Grid topic, okay, because we are listening to those topics. And then you would specify the input type or the output. In this case, you can choose Azure Function, Webhook, Event Hub, storage queues, Service Bus queues, etc. I already created an event subscription with an endpoint type of Azure Functions. Okay, so whenever I publish anything to this specific topic called demo-topic, it will trigger this Azure function, which is called test demo node, and specifically this function called event grid trigger. So in this Azure function, I defined the input binding as an event grid trigger, because again, I want the event grid to trigger this Azure function. Now, in order to publish events to this specific topic, I created a very simple PowerShell script which does that. I took it from the official Azure documentation. And if I run that, I have to first log in. And let's give that a bit. So all I'm doing, guys, is just I'm creating a demo event here. So basically, just with that specific subject, with that type, and that data, Ducati Monster. Let's give that a bit, and let's check the Azure function to see if it actually triggered. So we got a 200 status code now, and if we go back to Azure Functions, as you can see, guys, this function was executed by an event grid. As you can see, reason equals event grid trigger. And the reason why the event grid triggered this Azure function is because, again, we have defined a subscriber to that topic, and that subscriber has an output of Azure function type. Now, I want to specify something very important, and that is in the Azure portal, you can create event grid topic, and you can create an event grid subscription resource. So if I go to event grid subscriptions, I can create an event grid subscription. Okay, now you might ask, okay, why would we create that? So you can choose Azure built-in events. So again, you can choose, firstly, event grid topics if you are publishing custom events, which is exactly what I demonstrated now, where I used PowerShell to publish custom events. And here you would choose event grid topics, but instead of doing it from the event grid topics resource blade, you would use it from this blade. But typically, you would create an event subscription resource by itself when you want to leverage Azure built-in events. And again, guys, on Azure, you have a lot of built-in events for different Azure services. So for storage account, you have built-in events for storage uploads. And similar is for, the case is similar for Azure App Services. You have built-in events for SignalR servers, for Azure Map Service, a lot of different services. So in this case, you would define a subscription to Azure built-in events, and then you would define the outputs. So in this case, I won't demonstrate that, but I can simply choose storage account, built-in events, okay? And then I would specify exactly what the event type is. In this case, I'm looking for blob created event. So let's say I am listening to a blob created event. I would choose that, and then I would define the output type, which is the Azure function. And now, anytime I create a blob in a specific storage account that I choose, it will trigger that function up. So this is an example of how you would leverage Azure built-in events. Now let's talk about Azure Service Bus. Azure Service Bus is simply a messaging broker. You have a message publisher writing messages to the broker, and the broker delivers the messages to the consumers. In Service Bus, you can publish messages to either a message queue if you want one consumer to consume it, and this is known as FIFO, meaning first in, first out, or you can publish the message to a topic if you want multiple consumers to consume the same message. Let's revisit our previous architecture, modified a bit to highlight how Service Bus can be useful. I will demonstrate a queue in this example because I want a one-to-one relationship. We have a user simply making an order, which first goes to the web server. The web server talks to Stripe, which is the payment processor, and when the payment is confirmed, the web server will write a message to the Service Bus queue. The order processor will grab the message, process the order, and sends the confirmation that it is done to the web server. Now, the great thing here is that if anything fails in the order processor for some reason, it will retry again by pulling the message from the queue. And if it fails completely, even after retrying, the message in that queue will be written to a different queue called dead letter queue, and you, as the developer, can analyze those dead letter messages to see what went wrong. Now, on Service Bus, we have what we call entities, which we touched on. So the first entity is the queue, which relies on FIFO, first in, first out. So first message that goes in will go out. And this is for one-to-one relationships, as we just demonstrated here. But you can also publish messages to topics, which is the second entity. In this case, consumers can be more than one application, and that's if you want the message to be delivered to multiple services. So for example, in this case, it could be the order processor, and maybe you have a logger application that you also want to consume messages from. Now, the question is, why is Service Bus very useful? And in this architecture, we touched on a very important application of Service Bus in this case. But if we want to get specific, this is why Service Bus is very useful. And the first reason is dead lettering. Now, if a message fails to be processed in a queue or in a topic, even after retries, it will be sent to a completely different queue called dead letter queue. And you can still process those dead letter messages, okay, after you fix your code maybe. And most importantly, see what those messages are for debugging purposes. And the second benefit is what is known as message scheduling. So you can post a message to a queue or a topic, and you can specify the consumption time, which is when you want the message to be consumed. Lastly, it's another very important benefit when using Service Bus is duplicate message detection. Now, a huge challenge with any message broker is duplicate messages, because that's going to cause a lot of problems. And Service Bus is excellent at detecting duplicate messages. So now let's move to demonstrating Azure Service Bus. So in this case, I created an Azure Service Bus namespace called test43656. And what I will start with is demonstrating queuing in Azure Service Bus. So in this case, I created a queue called test, which I want to write messages to, and I want to consume messages from using my application. If I go to this test queue, in this case, you can see I don't have any messages right now written to this queue, and you can go to Service Bus Explorer to see what messages you currently have. And if I click on peek, you can see that I don't have any active messages. Now, if we go back to Visual Studio, I can go to my code, which sends messages to a queue. And in this code, you have to again specify the connection string, and that connection string is also created by creating a shared access policy and specifying the claims. In this case, I want to send to that queue and consume from that queue. Now, going back to my code, I just write the connection string, I specify the queue name, which is called test, and I write the body of messages. In this case, I'm just writing 10 messages with so that are very simple messages just for demonstration purposes. And at the end, I send those messages to this specific queue. So if I want to demonstrate that, I type node send to queue.js. Let's give that a bit. And as you can see, guys, it says sent a batch of messages to the queue test. And if we go back to the portal and we go back to Service Bus Explorer and we peek on that messages, we can see we have 10 messages being written here, as you can see. So it worked. Now we have messages in that queue, and you can see we're going to have message 1, message 2, message 3, etc. Now, how do we consume messages from that queue? Let's go back to another example code, which is receive from queue. It's almost the same exact code. You have to still specify the same connection string because, again, the shared access policy has both a send and listen claim. You also specify the queue name that you want to consume from, and then you go through some series of code written by the Azure Service Bus SDK. So if I want to demonstrate that, I type node receive from queue.js. And as you can see, guys, I received all those messages from a queue. And notice that they are ordered, guys, because again, we are dealing with FIFO, which is first in, first out. And if we go back to Service Bus Explorer and we do another peek, we should see 0 messages now. And that's true. So we have effectively sent messages to that queue and consumed messages from that specific queue. So that's demonstrating how you would deal with queues. Let's now demonstrate how you would deal with service bus topics. Again, you would use service bus topics if you have more than one subscriber, meaning more than one application that wants to consume from that same topic. Okay, so if I want to go to this test dash topic that I created, and so far I only have one subscription, which I'm going to demonstrate. This subscription or subscriber is called subscriber dash 1. Okay, I still have that shared access policy created with the same claims, send and listen, because I want to send to that topic and consume from that topic. If I do a peek for using Service Bus Explorer, and in this case, I have to choose a specific subscriber because, again, guys, each subscriber will have its own unique view on the same messages. So in this case, if I choose this specific subscriber who did not consume anything, I should see 0 here in this case because I don't have any messages. If we go back to the code, to the send to topic.js, again, we specify the connection string. And in this case, we specify the topic name, which is called test-topic. Okay. And I'm writing the same exact messages, message 1, message 2, etc. until message 10. Okay. And if I demonstrate that, node send to topic.js, let's give that a bit. As you can see, we have successfully sent these messages to this topic. And if we go back and then do another peek, I should see 10 messages. As you can see, guys, I see 10 messages in that topic. Now, if I have more than one subscribers, all of those subscribers are going to see the same messages. That's why we use topic, guys. If you want more than one consumer. In this case, I'm only demonstrating with one subscriber, but you can apply that to more than one subscriber. Now that I have 10 active messages, let's demonstrate how you would consume those messages. So if I go to receive from topic.js, again, I define the connection string, the topic name, but now what is different here is you have to specify the subscriber name because, again, every subscriber is responsible for consuming these messages. They kind of like have their own views. In this case, I want subscriber 1 to consume from this specific topic. Okay. If I run that code, node receive from topic.js, cool. I have successfully received all of those messages. And if I go back to Service Bus and I do another peek, I should see 0 messages. Okay. So now let me demonstrate how you would write messages to a dead lettered queue. Again, as I explained previously, if your application fails to process the messages, instead of those messages just completely going away, those messages will be written to a dead lettered queue. And this is super useful for you as a developer because you can find out what specific messages caused errors in your application or cause your application to fail to process those messages. So in this case, I'm going to simulate throwing some errors in processing those messages to show you how those messages are getting written to a dead lettered topic in this case. So let's go back to Visual Studio and I'm back to send to topic.js to send some messages to this topic because now I don't have any messages because I already consumed them. In this case, I'm only sending 2 messages. So if I want to demonstrate that, node send to topic.js. And if I go back to Service Bus Explorer and I do a peek once again on the subscription, I should see 2 active messages as you can see. So I have message 1 and message 2. Okay. If I go back to receive from topic.js, I have this function that handles the messages, okay? And inside that function, I'm throwing an arbitrary error. Now, I'm throwing this error to simulate a failure in processing those messages. Now, this function or this message handler, all I'm doing is just console logging the received messages. But in your application, you probably do a lot more complex message processing. In this case, I'm just throwing this error called error occurred, okay, just to simulate how those 2 messages will now be written to a dead lettered queue. So if I type node receive from topic.js, I should see 2 errors being thrown. That's okay. And if I go back to peeking once again, let's go to Service Bus Explorer and then to peek, and then I choose this subscriber. As you can see, guys, I don't have any active messages, but I do have 2 dead lettered messages, okay? And me, as a developer, I can check the dead letter or the messages being written to the dead letter topic, and I can find out those specific messages and see why those specific messages caused errors in my application. Now this brings us to another huge question, which is when to use which service, Azure Event Hub, Azure Event Grid, or Azure Service Bus. So with Azure Event Hub, you use Azure Event Hub if you are first dealing with events, meaning you don't care if someone consumes those events, and if you want a service that handles millions of events. Perfect example is a data streaming service. Data streaming means that you are continuously pushing data to a service, and that service is streaming that data to consumers. Now, it is a pub-sub model where you can have multiple consumers of the same event, and because Event Hub can handle millions of events, it is perfect for big data pipelines. So in the case of Event Hub, it actually uses a pull method where consumers have to pull events for processing, and Event Hub cannot trigger anything and relies on consumers to act. And this is as opposed to Azure Event Grid, which also uses events, but not for data streaming purposes, rather if you want to react to things. So on Azure, we have what we call built-in events, which I demonstrated in my previous module, that are published to Azure Event Grid without you having to configure anything. So for example, anytime you upload to blob storage, that emits an event to Event Grid, which is there ready to be processed. Now, you can also obviously upload your own events, like a user clicking a button on your website. And the good thing about Event Grid is that it is super fast, which is why it is used in what is called event-driven programming or reactive programming. So anytime you have an event-driven process, Event Grid is a great service to use. Now, Event Grid uses a push model as opposed to a pull model in Azure Event Hub, where events are pushed to subscribers, and if they aren't handled, they are just gone. So Event Grid, unlike Event Hub, can trigger things like Azure Function, Logic App, webhook calls, etc. Finally, we have the Azure Service Bus, and you use Azure Service Bus if you are dealing with messages, meaning you expect those messages to be processed. And the perfect example is the e-commerce application that I demonstrated previously. So with Azure Service Bus, you can use topics if you want to go with a pub-sub systems with multiple consumers, or a queue if you just have a single consumer, so a one-to-one relationship.